Hey guys, welcome to the video for graphing systems of inequalities. We are in Unit 5. Our essential question is, how are systems of equations and system of inequalities different? So I introduced Unit 5 with how we're going to be dealing with two equations instead of one equation. And when we're graphing, we'll have two equations instead of one equation. And I mentioned that there are three ways to solve a system, and the first way to solve a system is by graphing. So we learned how to graph systems of equations, and now we're going to learn how to graph systems of inequalities. Before we get into that, we need to review what inequalities are. So we have four inequalities in algebra. Okay, so these are our four. The first one is known as the less than inequality. And remember, it looks like an L, so kind of like less than, like an L. Okay, the second one is greater than or more than. I usually refer to it as greater than. We have less than or equal to, and greater than or equal to. Okay, so these are our four inequalities. Now, when we graph inequalities, there's two types of things we have to talk about. Is it going to be a solid line or a dotted line when we graph? So normally with equations, we just draw a line through all of our points and then we're done. But with inequalities, we have to talk about whether we need to have a solid line or a dotted line. And so for the first two inequalities, we would have a dotted line actually. Because there's no equal to here, so it's not contained in that. And then for the second two inequalities, we would have a solid line when we graph. So the way I have you remember this is if you see a solid line underneath, then you have a solid line when you graph. Okay, so if there is an equal to solid line, when you draw your line through all your points, it will be a solid line. And the second thing we have to talk about is whether or not we have to shade above or shade below. So if we have less than, we want to shade below. And if we have a greater than, we would shade above. So in the first one with less than, we would shade below. In the greater than, we would shade above. Oh, my handwriting is getting a little trashy. Let me fix all this. So the less than would be shade below. Greater than would be shade above. Less than or equal to, doesn't matter that it's equal to, it's still less than, so we would shade below. And this, again, is review. We learned about this in Unit 3. And then greater than or equal to is shade above. Okay, so moving on. When we're solving systems of inequalities or an inequality problem, we want to remember that when we are dividing or multiplying by a negative number, anytime we're multiplying or dividing by a negative, the inequality sign is going to flip the other way. So if we're multiplying or dividing by a negative number, the inequality sign flips. So that's super important because if you forget to flip your sign, then guess what? You're shading the wrong way. All right, now once we've shaded in our graph, right, so let's say I have an example here. Now this is just a random example, you don't have to write this. But let's say I drew my line, it's a dotted line, and I shade below. So you shaded below on this graph. Well, then I ask you, where are the solutions? Well, the solutions are going to be in your shaded region, okay? And then the non-solutions are in the non-shaded region. So if it's in the shaded, that's where your solutions are. So remember, solutions are anything within that shaded area. It's not just a single point. So it could be anything in that. So not everyone's solutions are going to look the same. And same thing with non-solutions. So non-solutions is non-shaded, and solutions are in the shaded. All right, moving on to the next page. So here we're going to start graphing. So when we have a system of inequalities, the solution is not a single point. Instead, is a region of points in a shaded area. Now, when we graph two systems or a system of equations, so this is just a random example, so you do not have to write this down or write this at all. But you would graph two equations, and then I would be like, hey, what's the solution? Well, the solution would be where they intersect. But when we're talking about system of inequalities, that's not the case because it doesn't matter if they intersect. We're looking at the shaded area. So normally when we would graph, I would be like, hey, let's graph this, and I don't know, let's say it's some random thing and it's a greater than or equal to. So I know that it has to be a solid line when I graph it. and I need to shade above because it's a greater than sign. So normally I would shade above on it, right? But if I'm having to graph two lines here, all of the shading is going to get really messy. So rather than doing that, I want us to just draw some arrows that show us which way we should shade. Okay? And then let's say for our second equation, it's a less than sign. So let's say I plot the line, I put my points down, and then I draw a dotted line through all of my points. Again, this is just a random example. So this is a dotted line because there's no equal to here. And then it says less than. So that means that I would shade below. Well, on my green line, I would put arrows pointing down on the below side. Okay? And then you're like, okay, now what? Well, the part where you want to shade is where your two arrows are pointing to each other. So if you notice, in this section over here, the green arrows and the blue arrows are both pointing in the same direction. So this is where you would want to shade. So it's where your two arrows are pointing to each other. You would not want to shade in this area because the blue arrows point, but the green arrows don't. So you want both of your arrows to be pointing in the same direction. And this will get easier as we go on. That was just a random example just so I can let you know, hey, don't shade yet, just be very careful. Okay, now when we're graphing inequalities or equations, we prefer to have it in slope-intercept form, y equals mx plus b. So we want to try to get y by itself. So I'm going to do the first inequality in green. Well, I notice that y is already by itself, so I can go ahead and start. Well, what's my slope here? Well, my slope here is going to be the number in front of the x, so this is a -1. So my slope here is -1 over 1. My y-intercept is positive 1, so 0, 1. So I'm going to go ahead and graph this inequality first. I want to do one at a time because if I try to do them both at the same time, it gets kind of confusing. So the first thing I'll do is plot my y-intercept on the y-axis at +1. And then I go down 1 and then to the right 1. And I'm going to keep doing that on my entire graph for the entire, or however much it lets me, right? So I'm going to do as much as I can. And you want to go in the other direction as well. Okay. So I have all my points. Now before I draw a line through this, I have to check my inequality sign. Well, my inequality sign here is greater than or equal to. Because it is equal to, then I know I have a solid line. So I'm going to have a solid line here. And then the next thing I have to think about is the shading. Would I shade up, above, or would I shade down, below? Well, this is a greater than sign, so I would shade above. Now, without actually shading, I'm just going to draw some arrows. Now, you're like, well, how many arrows do I draw? Well, I like to draw a good amount. I don't want to draw just 2, but I do want to draw a few on my line so I know where it's pointing. So I'm shading above here. But I'm not going to actually shade it in until I get to my last part. Now, in the second inequality, I'm going to do in blue. And I know I can move on because I finished with the first inequality. I've done all I needed to do. Okay, so in this one, I need to get y by itself. So the first thing I would do is subtract 5x on both sides. So I have -2y is less than 6 minus 5x. Okay, next step here is we want to get y by itself, so we have to divide everything by -2. But because I am dividing by a negative, my sign will flip. So I have y as greater than, right, because now my sign has flipped the other way. 6 divided by -2 is -3. -5 divided by -2 is +5 over 2. And then we have our x. So now y is by itself, so I can identify my slope and my y-intercept. My slope here is +5 over 2. And my y-intercept here is 0, -3. So I would start on my y-axis at -3. And I would go up 5, 1, 2, 3, 4, 5, and then to the right 2 because it's a positive slope. Now I can't keep going because my graph doesn't really extend that far, but that's all right. Now before I draw my line through these 2 points, I have to talk about whether or not I have a solid or dotted line. Well, again, we're not looking at this inequality anymore. We have our new inequality down here. This says greater than, and there's no equal to sign, so that means I have a dotted line. Because there's no line underneath, right? There's no equal to line, so I have a dotted line. And where would I shade in this case? Well, I have a greater than sign now, so I would shade above. So above my line, I would draw my arrows pointing up. Okay, and now you know where you're supposed to shade because that's where your 2 arrows are pointing to each other. So I would shade in this region up here. And make sure you shade in the entire region so that you can see the whole region. All right. Okay, and then the very last thing is we need to identify a solution and a non-solution. And so like I said at the beginning, your solution can be any number inside or any point inside the shaded region. So a solution could be 1, 4. 1, 4 is in this shaded region here. Or I could have the point 0, 5. 0, 5 is right here, is in the shaded region. So again, there's lots of types of solutions I could have. A non-solution would be something not in the shaded region, so maybe 0, 0. Or -3, 0, because -3, 0 is over here. So again, anything in the non-shaded would be a non-solution. Okay, moving on to the second problem. Y is less than 2x and y is less than 4. Well, here I notice that both of my inequalities already have y by themselves, so I can go ahead and start. So I'm going to start here. Y is less than 2x. So my slope here would be positive 2 over 1, and my y-intercept would be 0, 0, because there's no number being added or subtracted back there. So I would start at the origin 0, 0, and I would go up 2 and to the right 1, because we have a positive slope. Or I can go down 2 and to the left 1. Before I draw a line through this, I have to check, is this going to be a solid or dotted line? It's going to be a dotted line. There's no equal to there. So we want to make sure we have a dotted line here. Make sure we have our arrows on the end. And that is a less than sign. So if it's a less than sign, then I would shade below. So I'm going to draw my arrows and point below, because this is below my line. Okay, and my next one, because I'm done, all right, I've already done my line, and I've talked about shading, so I'm good there. In my next one, I have y is less than 4. Well, this is just y and a number, which means it's either going to be on the y-axis or on the x-axis. Well, since it says y, then I'm going to look at my y-axis and put a point at positive 4. Okay, remember, so it's just y and a number. So this would be y and just the number 4. And then before I draw a line through this, I have to think about, does it go up and down, or does it go side to side? Remember, our tick marks on our y-axis go side to side. So our line here is going to be side to side. Before you draw that line, is it going to be solid or dotted? It's going to be dotted. There's no equal to there. So we have a dotted line. And it says y is less than 4. So if it's a less than symbol, then we're going to shade below. Okay? Okay, well, where are all your arrows pointing to each other? In this section here, the blue arrows and the red arrows are both pointing in the same direction over here, so this is where I shade, is in this bottom area. Whoops, I keep messing up. I need to make my highlighter a little bit bigger. So all of this over here. Now, let's talk about this. Is the point 0, 0 a solution? So I forgot to mention this at the beginning, but, well, we see that 0, 0 is on the line. So you're like, well, maybe it's a solution. But if it's on a dotted line, it's not a solution. So if you want to write that, if the point is on dotted line, it's not a solution because it's not included, right? It's not equal to there. But if the point is on a solid line, then it is a solution. So in this case, 0, 0, even though it's on the line, it's on a dotted line. So would it be considered a non-solution? Okay. Well, what would be considered a solution? Maybe the point, I don't know, 5, 0, right? Because it's out here. Is that 5? Yeah, that's 5, 0. 5, 0, that's considered a solution because it's in the shaded. But like for the example, like 0, 0, even though it's on the line, it's not a solution. The point 1, 2, again, still not a solution. All right, moving on to number 3. So both in my inequalities, my y is not by itself, so I want to get y by itself. In the first one, I'm going to subtract x on both sides. Y is less than or equal to 3 minus x. Do I need to do anything else? No, because y is already by itself. Our slope here is negative 1 over 1, and our y-intercept is 0, positive 3. So again, I'm going to deal with this inequality first before I move on to the second one. So this one is going to be positive 3, and my slope is down 1 to the right 1. So I have a negative line here because I have a negative slope. Okay, now I'm looking at my inequality sign. There is a equal to line, so it is going to be a solid line. And then it says less than or equal to, so less than means I shade below. All right. Let's move on to the second inequality. And we get y by itself, so subtract 4x on both sides. So we have 4y is greater than or equal to negative 4 minus 4x. And then you're going to divide everything by 4 because you're trying to get that y by itself. So you have y is greater than or equal to. We do not flip the sign here because the number you're dividing by is a positive 4. So do not flip the sign here. Negative 4 divided by 4 is negative 1. Negative 4 divided by 4 is still negative 1. So we can have negative 1x or just negative x. Our slope here is negative 1 over 1, and our y-intercept here is 0, negative 1. So we're going to start and put the point negative 1 on the y-axis, and then we're going to go down 1 to the right 1. So it looks like our lines have the same slope. So our lines are parallel. But again, that doesn't mean no solution because we were talking about inequalities, so we're shading here. We're looking at the shaded region. So just because they are parallel does not mean it's no solution. All right, now to do our line here, well, I have an equal to line, so it's going to be solid. And then it's a greater than or equal to means a shade above. So where do you notice the arrows are pointing? Towards the middle. So that means that middle section is the point, is where all the solutions are, is in this shaded region. All right. So let's pick a solution. Solution's anything in the shaded, so I could pick the point 0, 0. And then anything in the non-shaded would be a non-solution, so I could pick the point, why not, negative 5, 0, or negative 7, negative 7, right? Anything in the non-shaded. Moving on to number 4. I know this is a lot of kind of the same thing, but it's good practice, and they're all a little different looking, so it's good to just continue to stick through this. All right, so in the first inequality, y is not by itself, so let's go ahead and subtract. Well, actually, we're not subtracting here, right? We want to add x to both sides. So here the order is a little bit different than what we're used to, but we're still trying to get y by itself. So 3y is less than or equal to 9 plus x. Okay. And then the next step here is divide everything by 3. So then we have y is less than or equal to 9 divided by 3 is 3. The number in front of the x is a 1, so we have positive 1/3 x. Our slope here is 1 over 3, and our y-intercept is 0, 3. So we're at the y-intercept of 0, 3, and then we're going to go up 1 to the right 3. And so we're going to do that as much as we can on our graph, as much as it'll let us, right? And then to graph this, I want to look at my inequality sign. It is going to be less than or equal to, so it is going to be a solid line. And it says less than, so I'm going to shade below here. So I'm going to put some down arrows to say below. It helps us with not too much shading because it can look a little scary if we shade way too much. Let's pick, what do I have up there? Let's do red. Okay. So here, let's first get rid of those parentheses, right? Let's distribute. So we have x minus 3y is less than 3 times 1 is 3. 3 times negative y is negative 3y. All right, so normally we like the y to be on the left side. So we want to move this guy over here. Well, to do that, we would have to add 3y on both sides. Well, what happens when we add 3y here? Well, that's going to cancel, right? Because negative 3 plus 3 is 0. What about on this side? Negative 3y plus 3y is 0y. What's 0 times y? 0. Goes away, right? If I owe you $3 and then I give you $3, I owe you nothing. So this thing goes away entirely. So all I have left is x is less than 3. Now this is just x and a number, okay? It's just x and a number, which means I'm going to look at either my x or my y-axis. Well, since it's x, I'm going to look at my x-axis and put a point at positive 3 because I see a positive 3 there. Remember, these tick marks go up and down, so my line is going to go up and down here. But will I have a solid or dotted line? I'm going to have a dotted line because there's no equal to line there. Okay, so I'm a dotted line. It says x is less than. Now, in this case, you're like, well, which way do I shade? There's no up, above, or below. But we have a left or a right. Well, let's think about it. We have x is less than 3. Where are all the numbers less than 3 on the number line here? they're all on the left side. So we would shade to the left in this case, because all the numbers less than 3 are to the left of 3. So looks like my shaded region is going to be over here. Both of my arrows are pointing this way. Right, okay. All right, so let's talk about solutions. Well, 0, 0 is a solution. And let me ask you, is the point 0, 3 a solution? 0, 3 is right here. It is on the line and it's a solid line, so 0, 3 would be considered a solution. But let me ask you this, is 3, 0 a solution? Is this point considered a solution? No, even though it's on the line, it's not a solid line, so it would be considered a non-solution. And then another non-solution could be the point maybe 0, 5, because 0, 5 is all the way up here. So, oops. So just a reminder that solutions can be in the solid lines, they can be on solid lines, but they can't be on dotted lines. All right, moving on, we have 2 more problems left. Number 5, y is already by itself in that first inequality, so we're good there. Our slope is going to be -1/1, and our y-intercept is going to be 0, -1. So we're starting at -1, we go down 1 to the right 1. Before I draw a line through this, I want to check to see what my inequality sign is. It is just a greater than, there's no equal to, so I know this is going to be a dotted line. Okay, now it is a greater than symbol, so I would shade above in this case. All right, let's do the next inequality. So it's going to go ahead and subtract x because we know y is not by itself. We have y is less than 2 minus x. Our slope here is -1/1, and our y-intercept is 0, 2. So we plotted point at 2, and then we have down 1/1. Down 1 to the right 1. So we just keep going. Again, I notice my lines are parallel to each other, but that should not matter because we're talking about inequalities and we're shading here. So if it was just regular lines in equations, it would be no solution, but we're talking about inequalities. Now this is no equal to, so this one is also going to be dotted. And this one is a less than symbol, so it's going to point below. Well, both of my arrows are pointing to that middle section, so I'm going to shade in the middle. So all of my solutions are in the middle section here. So one of my solutions could be the point 0, 0. And then a non-solution could be the point 5, 0, because it lands out here. So go ahead and pick a different color. All right. Last one. In that first one, my y is already by itself. My slope here is -2/1, and my y-intercept is 0, positive 3. So I'm going to go up 3 positive, and then we're going to go down 2 to the right 1. So this is a negative slope, so make sure when you're graphing the slope that it is in the negative direction. Before I draw a line, I check. It is equal to, so I am going to draw a solid line. And it says greater than or equal to, so I'm going to shade above. Okay. In the next line, or next inequality, I need to get y by itself, so I'm going to subtract 2x on both sides. Y is greater than or equal to 5 minus 2x. My slope here is -2/1, and my y-intercept is 0, positive 5. So I have positive 5, I go down 2 to the right 1. So then again, it looks like my lines are parallel to each other. And before I draw a line through these, I check my inequality sign. It is an equal to, so I have a solid line when I graph this. And then it says greater than or equal to. So these are also pointing up. They're pointing above. So you're like, well, where do I shade? Well, again, you shade where the arrows tell you to shade. So if the pink says go up and the purple says go up even more, then the portion where you want to shade is going to be on this side of your graph, over here. Okay? Now, why would you not shade in this section. Because even though the pink arrows point that way, your purple arrows don't point towards the middle. So you're going to be super careful about where you're graphing or you're shading, right? Because all the arrows are pointing up, you want to only shade up that portion on the up section. All right, so a solution, anything in the shaded, so I could do the point 3, 3, that's in the shaded. And then a non-solution would be the point 0, 0, because it's in the non-shaded. All right, so that is just graphing inequalities. It is not that much extra from graphing equations, just that you have to think about where you want to shade and whether or not you have a dotted or solid line. And just because two lines are parallel doesn't mean it's no solution. Because remember, you're looking at shading here. If we were just graphing regular equations, it would mean no solution. If you have any questions, just please feel free to come in for tutoring.